Hello from the Forcetronics YouTube channel, and welcome to creating a sensor network that connects to the cloud, and this will be part one in a three-part series. Let's get started. Okay, when I say a sensor network connected to the cloud, what am I talking about? Well, this is just to sort of give you an overview of the architecture of this project. What I'll be doing is setting up a sensor network that could be considered a mesh network, meaning it's going to talk to a central coordinator and the nodes can actually talk through each other. So if you have a node that's farther away from the coordinator than another node, it can actually communicate through that node. So we'll have this mesh network that'll have sensors. For my sensors, I'm just going to be using temperature as an example, but you could be using other things for yours. And for the sensor nodes, I'm going to be using the Arduino combined with the low cost and popular maker community item, the NRF24L01. So these are going to be my nodes, Arduino plus the NRF24L01. Then my coordinator, I'm going to use an Arduino Maker 1000. And the reason I'm using the Maker 1000 is it's Wi-Fi capable, so it can connect to the cloud. We're going to use that to send data to the cloud. And then of course, it'll interface with another NRF24L01 to grab the data from the sensor network. Now, for the nodes, you can use different Arduinos. That's why I just wrote Arduino here. I'm using specifically the Arduino MKR 1000. You could also probably use an Arduino with the Wi-Fi Shield. You may also be able to use the popular ESP8266, but I've not tested it yet in this configuration. Okay, so we have our coordinator. We're going to send data to the cloud, and we're going to use the free cloud service by SparkFun called Font, and I'll talk about that. And then in the later part, we'll look at how to get the data from the cloud using a web browser, or we'll also make an example Android app to grab that data, that sensor data that we're collecting, and view it on a Android-enabled smart device. Now, one thing I want to mention is this. What we're doing is a pretty big task. We're setting up a mesh network, we're grabbing data, we're sending it to the cloud, we're going to view it on an app. And to get that all done in a three-part series is a lot of work. So what I am doing is I'm leveraging some of my past series. So if you watch all my videos on my channel, you've probably already seen these. If you don't, I have a 6-part series on creating a wireless sensor network with the NRF24L01 and how to use the libraries and set up a mesh network. So you don't have to watch that before watching this video, but if you do want to get down into what's needed for the hardware and the code for the sensor nodes, you're going to have to watch that series. And then I also have a Wi-Fi IoT series, and that covers a lot about using the Font Cloud as well as using the ESP8266 as well as the MKR 1000 to send data to the cloud. So I am going to refer to those videos as well as break new ground in this video. Okay, notes on the architecture. So I showed you the architecture, and in the picture, I just showed 3 nodes. You could have 5, you could have 6, you could have 10 nodes. There's really not a limitation. I'm just going to use 3 for this example. Here I asked the question, well, why even use the NRF24? I mean, in some of my past videos, the Wi-Fi IoT series, I show you how to use multiple MKR 1000s and ESP8266s to form a multi-node network and send data to the cloud. Why not just do that? Well, you can do that. There's nothing wrong with that, especially if you're doing simple sensors. The ESP8266 is pretty low cost. So why would you want to do this approach? Well, the NRF24L01s, their protocol is much simpler for sending just small amounts of data. So they use a lot less battery power, or I should say current, when they transmit data and send data compared to a Wi-Fi device. That's one reason. You could actually get, and I show it in my sensor video, is you could actually, using off-the-shelf alkaline batteries, you could get a year or more of battery life. You're not going to be able to do that with Wi-Fi, or at least it's very hard to do that. Also, another reason why you might take this approach is, let's say you're setting up a network outside in your garden, maybe you have a big garden outside and you want to monitor moisture or something like that. Well, maybe your Wi-Fi signal may not reach that far. So the NRF24 mesh network is very helpful there. And as long as one of them or multiple of them is close enough to the coordinator, which has the Wi-Fi signal, and the coordinator is close enough to your Wi-Fi router, you're fine. Another reason is the libraries out there, the open source libraries out there for the NRF24, make it really easy to set up a mesh network. I did see an example mesh network using the ESP8266, but Wi-Fi in general is not a great standard for setting up mesh networks, but you can do it. But these are the three reasons. The first one being one of the strongest reasons why you would go this approach. Okay, here we're looking at an example of the hardware I'm using. And so here is the coordinator. Here's the MKR1000, the Arduino Maker 1000, as well as the NRF24L01. I will note, just a shameless plug, I do sell Maker 1000s on my website, forcetronics.com. I also sell this mini proto board for the NRF24L01. Now you can connect it with just wires, but this has a capacitor and it has a nice neat connector and pins to put it on a breadboard if you're interested. Then these puppies over here are my wireless sensor node, or actually it's not called that, it's called the wireless flex node. So this board right here is something I built in the wireless sensor network series that I mentioned. So in that series, I talk about the software and I talk about how to build the hardware to create this. You don't have to use this hardware setup. You could use an Arduino Uno with the NRF24L01. I'm using this just because I have them, but you could just use, any AVR Arduino. This design here, I also sell on my website, forcetronics.com. It runs the Pro Mini bootloader. And so here the NRF24 goes right on it. It has your Arduino chip running the Pro Mini bootloader. I have a temperature sensor right here. I can take in battery power or I can power from wall power. But once again, you don't have to use that. You can use the Arduino. Now, I'm not going to go over the code for these. You'll have to refer to the wireless sensor network series. You should note though, if you get the code from that series, I'm not altering it for this series. I'm using the code from that series. Okay, let's take a look at the network in action. Okay, here we are looking at the code and the serial monitor, and you can see that every once in a while I have the node set for a minute. Every minute they send some temperature data. They also send the status of their battery. A 1 means that the battery is good. And so here you see the temperature, you see the battery status, you see the node that it's coming from. You have to number the nodes, and once again, that's in the wireless sensor network series. So this is coming into the Maker 1000, and then what the Maker 1000 does is it then sends it to the cloud. So I actually have a line space in here, but you can see sent data to the cloud successfully. Every minute, the temperature sensors send in data, then the Maker 1000 gets the data and sends it to the cloud. If you see my sensor network video, I show you how to set up 10-minute intervals or 15-minute intervals. Here I'm sending data every minute. I even show you how to do it every second as well. So here we can see the data coming in on the serial monitor, but we can also see the data coming in here on the cloud. So actually, let me start here. Here is a free service that SparkFun has set up, data.sparkfun.com. I go in more on this in detail in the IoT series, the Wi-Fi IoT series, but this is a free program they made. You can create your own sort of cloud nodes, and you basically define the data you're coming in. The data comes in, they tell you what type of language you need to use, or I shouldn't say language, the wording you need to use to send gets and posts to the web, to post things to their cloud. You can also get data from the cloud as well. So if you follow these steps, it's real easy to set it up. Here you're actually looking at a setup I created, and here I just have node 1, node 2, and node 3. And you're looking at these numbers and you're like saying, well, what do these mean? Well, their cloud program can't support decimal points. So what I do is I multiply the temperature by 10 to save 1 decimal point. So you can see we have 66.2 degrees Fahrenheit, 65.3 degrees Fahrenheit, and 66.2 degrees Fahrenheit. And they also timestamp it. So here we get the data in the cloud. I will note too that SparkFun, this is an open source cloud software. So right now we depend on them to host the cloud, but if you actually wanted to host this software on your own server, you can, because they provide it open source. Okay, so there's our temperature data coming in. You can actually see here where I turn each node on. So I turn node 3 on first, I turn node 1 on second, and then node 2 on third. And I can tell that because when they first turn on, they immediately send a temperature value, and then the Maker 1000 posts it to the cloud. Okay, with that said, let's look at the code that we're running on the Maker 1000. Okay, here we have the code. You're gonna actually see, I'm gonna have some things blurred out because I don't want my network codes out on the web, of course. Here are the libraries we call, and this is where you may want to look at the code from the wireless sensor video series, because here I'm using 2 libraries that are open source on GitHub that were made for the NRF24 L01 transceivers. The first one is just basic radio communication. The second one, though, is the network one, and this adds a wrapper to basically allow them to act like they're on a mesh network. So these 2 libraries go together. Notice that I have RF24 network no sleep. That's because I had to modify this one to work for the Maker 1000, and I'll talk about that later. Here I make a call to the SPI communication library because I need my SPI communication. And then here is Arduino's Wi-Fi 101 library that you need for the Maker 1000 or the Wi-Fi Shield. Here's where I set up my network name and network password for the Wi-Fi library. This interval and start I actually don't think I need, so I'll probably erase them out. Here are my global variables for holding the sensor data, so temp node 1, temp node 2, and temp node 3. Here I use the LED, the built-in LED on the Maker 1000 to signal when I connect and send the Wi-Fi data to the cloud. Here are my things I need for the Font Cloud. So I need the web address, I need my public key and my private key. And that's things that they give you when you set up your own little cloud variables. Here's some code that I actually leverage from SparkFun that helps build the string to send data to the cloud. So these are just kind of strings that are being stored, and I leverage that from SparkFun code. Here's where I make my radio call. So now I'm configuring my objects for the NRF24. I was just talking about Wi-Fi. Now we're talking about the NRF24. I set up my radio object and then my network wrapper, and I feed in the radio object to the network wrapper. I then define the coordinator as node 0, and then the other nodes, the sensor nodes, are going to be node 1, node 2, node 3, and then you can actually set them up to talk through each other, which I discuss in the wireless sensor series. Here's my payload. So this is a structure, and I'm saying from the other nodes, I'm going to get in a temperature reading, which it says ADC temperature, but actually not an ADC reading. And then I get the state of the battery. So that's the data I'm getting from the network from each node. Once again, you can just add more data or different data if you want to by rearranging this payload, both for the coordinator and for the nodes. Here's my setup code. I start with the serial begin. The code will stop here until you open the serial monitor. So it won't run until you open the serial monitor. I tell the user that the coordinator is online. Here, if you're using the Wi-Fi Shield, which I have not tested this code for, but it should work, this will tell you if you don't have the Wi-Fi Shield connected. I then connect to the Wi-Fi network. I then loop until my connection is good, and then I tell the user I'm connected to Wi-Fi. I then start my other things, my network layer, my radio layer, and my SPI communication. Now here's where I go into the main loop. So this network update call updates the mesh network. So if a new node comes on here, it'll add it to there. So you just need to call this every once in a while in the loop. Or actually, I shouldn't say every once in a while, every so often in the loop. Here is a header. Once again, this comes from the network library, and this header just is used to basically tell what node sent the data. This is another structure. Here's my payload structure. I named my payload structure payload lowercase. I then set the portion of the payload, the temperature reading, to 0. I use that to tell if I got new data. Then I only go into this loop if I have new data. So if network.available, and once again, when I say new data, I'm talking about from the sensor network. I then grab that data with this network.read function, so you can see my header, there's my payload, and then I have to specify the size of the payload. I then use the serial monitor to print out the information, the node, the temperature, the battery status. I then use this function call, which I'll show you, to store the node data, because this is just a local variable, so I store it into a global variable. I check if there's new data, because remember, this loop just keeps going around, and only if I get new data will this variable be non-zero. So if I got new data, I call this function, which I'll show in a second, post to font, which font is the cloud. So this is what posts to the cloud. If it fails, I let you know. If it didn't, I let you know that it was successful. And then here's my post to font function, and I leveraged a lot of this function from SparkFun code, but first I turn the LED high. I then use these functions, which I'll show you I have below, and I leverage these from SparkFun to build my font strings. So this function call helps use the public and the private key. The public and private key are used to communicate with the font cloud to tell them it's your account. This is where you store this data. Then these font adds, these are my fields, my temp node 1, temp node 2, temp node 3. This just builds the strings to send the data, and I'll show you those functions. Here I make my Wi-Fi client, because your client is what you're going to use to talk to the cloud, because you are a client, the cloud is the server. I then do a connect, and I use the font host and port 80. Port 80 is just sort of the internet port. If it fails, I just return 0. Then I use the client to print. So I then call font post, which has built my post string. So I want to post something to the cloud. This builds that string. The client actually sends it to the cloud. I then just check if anything was returned. We shouldn't see anything returned to the client from the cloud. I then turn the client off. You want to make sure that after you're done, you do client stop, or else you'll open too many client strings that you don't close and you won't be able to connect. I then turn the LED off so I can tell that the post is done, and then I return 1 to show them a successful. Okay, and then here's the function that just stores the incoming node data to the global variable. So that's all that's happening here, and you can see here I multiply it by 10 so I can save that decimal point. Now, when I want to display the temperature data later, let's say on an Android app, I'll just divide it by 10. These functions are used to create the font strings, and I leverage these from SparkFun code, and you can read through these, but it's just building the strings to send and communicate with the cloud. Okay, piece of cake. There is some more I need to do with this code, and I'll talk about that at the end of the video. This is just part 1, the starting point. Okay, one thing I promised to mention was the changes I did to the RF24 network library. And once again, some of the stuff I'm going to talk about is going to make more sense if you watch the wireless sensor network video series. So from GitHub, there's a user named TMRH20, and that's the versions of the RF24 and the RF24 network libraries I'm using. And in that library, he or she, I guess I don't know, has a config file. And for my nodes, I use sleep mode to save power. And so in the config file, I have to uncomment this define enable sleep mode. The problem is this is only for AVR based chips, so like the Arduino Uno or the Arduino Pro Mini. The problem though is the Maker 1000 is not an AVR Arduino. So if I uncomment this and then try to compile the Maker 1000 code using the same library, I get an error saying that this is not an AVR device. So what I did was I took another version of the library, I don't uncomment this out, and I even take out some of the AVR code to make the library a little more lightweight, and then I name it different. So that's why I have a different name library. The library is doing the same function for the MKR 1000. It's allowing you to add this network layer. It's just I had to change some things so it works with a non-AVR chip. And if you go to the comment section, or not the comment section, the description section for this video, I'll have a link to GitHub where I have all the code from this video, and I'll have the code for subsequent parts as well. Okay, that was part one. In part two, we're going to look at how to timestamp our data. So right now we're just sending raw temperature readings, but we have no sense of when they happened. We do have the font that does a timestamp, but I'm going to use the Maker 1000's real-time clock to do timestamping on the data. I'm also going to actually add code to check the battery levels, so we know when a battery's gone bad, we can actually do something and report that to the user. I'm also going to add a little more error checking in the code, because right now if I were to lose a network connection, the code is not going to act real well. So I'll add all that for part two. Then in part three, we'll look at getting the data from the cloud and the Android app. Okay, thanks for watching part one. And if you have anything to add, please use the comment section. And thank you for watching.